Welcome to the Visual COBOL in a Nutshell series of presentations. This module will cover advanced debugging techniques that can be used with the Visual COBOL for Eclipse product. Visual COBOL for Eclipse provides an extensive set of debugging tools that can aid you in identifying bugs in your applications before your customers do. Just-in-time or JIT debugging. JIT debugging can be used to cause a running application to automatically invoke the debugger when required, or to generate a core dump file when an error occurs in production. Some of the JIT debugging options that are available to you are: set COB switch equals +A for native COBOL programs only. When you set this environment variable and run a COBOL program, the Eclipse debugger will automatically start. You can embed calls to COBOL debug break within your program, which will also start the Eclipse debugger. With JIT debug on error for native code only, when an error occurs in your program, the Eclipse debugger will automatically be invoked. And you can create a core dump in production that can then be debugged on your development machine using Eclipse. Let's take a look at some of these JIT debugging options. We have two programs to demonstrate just-in-time debugging. The first is called JIT Debug. We'll use this program to demonstrate having the code explicitly invoke the debugger as needed. The program is written to check the command line to determine whether a /d parameter was passed. And if so, the program calls a COBOL library routine named COBOL debug break, whose job is to invoke the Visual COBOL debugger if the debugger is available. The second program is named JIT error. In this case, the program does not have an explicit call to COBOL debug break. However, this program is coded to cause an error to occur because of a bad subscript. Before we start using the JIT debugging options, we need to turn on this feature in Visual COBOL for Eclipse. To do so, on the Eclipse menu, go to Window, Preferences, and then drill down into Microfocus, COBOL, Debug. Ensure the Enable JIT Debugging option is checked and click OK. Now we can exit Eclipse. From the Windows Start menu, I've gone to Microfocus Visual COBOL, then Tools, and finally Visual COBOL Command Prompt 32-bit to start a command prompt. This sets up the environment in this command shell with default values for running COBOL. I'll change the current directory to the output folder for the project, which contains the executable files. First, I'll invoke the JIT debug program without the /d option. When run this way, the program runs normally. Next, I'll invoke the program with the /d option. In this case, remember the program will invoke the COBOL debug break routine, which causes Eclipse to start so that the program can be debugged. When Eclipse starts, we're prompted to confirm the workspace Eclipse should use. Make sure the workspace containing the program to be debugged is selected and click OK. It may take a moment for Eclipse to open your workspace and the program being debugged. It then places us in the debugger at the call to COBOL debug break. From there, we can continue to debug normally. So, that's one method of using JIT debugging. I'll close Eclipse again and try another method. In this case, I'll set the environment variable COB switch equal to +A. This causes the debugger to be invoked as soon as the COBOL program starts, rather than depending on a call to COBOL debug break. Since I don't need the call to COBOL debug break, I don't need to specify the /d when I invoke the JIT debug program. This time, I'm positioned at the first line of code in the procedure division. Once again, I can debug normally from here. Another effect of turning on the just-in-time debugging option in Eclipse is that COBOL programs which have been compiled for debugging will automatically invoke the debugger when a runtime error occurs, even when they are run at the command line outside of Eclipse. We can demonstrate this with our program JIT error. This program will loop until it tries to access the 11th occurrence in a table that only contains 10 occurrences. Let's exit Eclipse and try running it from the command line. The COB switch variable we saw earlier is not required for this automatic invocation of the debugger on a runtime error, so I'll unset it. Now I'll invoke the program. When it encounters the error, Eclipse is automatically invoked and displays the runtime error. After I click OK, the debugger is invoked, and I'm positioned to the line of code where the error occurred. I can inspect the contents of data items. However, I cannot continue execution after a runtime system error. I can fix the code error, but when I save, I'm told the program won't be rebuilt until the debugging session is completed. After I click the Stop button, the program is rebuilt. When I exit Eclipse and run the program again, the error does not occur, so the debugger is not invoked. Another option when a critical error occurs is to create a core dump. This is handy when your application is deployed to a production machine running the COBOL server product. In this case, you can still debug the application even though you don't have Visual COBOL for Eclipse installed on that machine. To enable the core dumped functionality, you can run a command named COBOL core D. Choose the option to enable the core dump. You can also enable core dumps using a runtime tunable named core on error, but we'll use COBOL core D in this demo. I've put the coding error back into the JIT error program. Now I'll run the failing program again and get a message that a runtime system error has occurred and has core dumped, telling me the name of the generated core file, CBL core. I could now copy that core file back to my development machine and use the debugger to display the status of the program at the time the error occurred. To do this, I open Visual COBOL for Eclipse using the workspace where the failing COBOL application was originally built. Next, I'll create a special debug configuration to invoke the debugger using our core file. From the menu in Eclipse, I'll choose Run, Debug Configurations. On the left, I'll choose COBOL Core Dump as the type of debugging configuration I'd like to create, and then click the New button above to create a new configuration of that type. I'll specify the COBOL project in which the failing application was developed, enter the location of the core file, and finally, click Debug. This starts the debugger, which immediately displays the error that caused the program to abort. We can't actually execute any statements when debugging a core dump, but we can look at the current state of the program, such as looking at the perform stack and viewing the contents of variables. There are a variety of advanced ways that the Eclipse debugger can be used for debugging your application. Some of the options that are available to you include Attach to Process. This allows you to attach the debugger to a program which is already running. Start External Program allows you to run a specified program outside the current project. This can be used for debugging DLLs or shared objects, or programs started from a non-COBOL language. Wait for debuggable attachment. In this case, the debugger will wait and attach to the first debuggable program that starts. You can further control this by specifying a directory from which the debugged program will be run. Another way to control this feature is to configure the debugger to look for a certain ID. This will respond only to a program that invokes COBOL debug start while specifying the matching ID. Finally, you can perform remote debugging against programs that are running on a remote computer. Let's take a look at some of these options. I have a workspace with a number of projects, each one demonstrating a different method of starting the debugger. First, let's look at attaching to a running process. To use the attach feature, the program must be started and must be in a running state. To demonstrate this, I'll use the program Start from Attach. This is a simple COBOL program that opens some files, does a display, and waits for user input on an accept statement. Since the program will wait until the user responds, this gives us time to attach to the running process. To start the program, I'll go to a Visual COBOL command prompt, cd to the new configuration.bin directory, which contains my project's executables, and execute the program from the command line. The program is now running and waiting at that accept. Now, within Eclipse, I can go to Run, Debug Configurations, and choose the option on the left for COBOL attached to process. I'll choose New to create a new run configuration of this type. I'll give the new run configuration a meaningful name and enter the name of the project that contains the running program. Then I'll click Debug. The Select Process dialog shows a list of the running processes. I'll enter some portion of the name of my running process, and the list is filtered. Finally, I'll choose my process and click OK. Because my program is actually in a low-level routine processing the accept statement, the debugger initially only shows the process as running in the debug view. I'll click the Suspend button on the toolbar, which temporarily suspends the execution of the accept statement, and then the debugger is positioned to the line with the running accept. Now I can continue execution with step into, and the accept statement is reactivated. I'll go back to the command prompt and press Enter to respond to the accept. And the debugger advances to the next statement. Now I can debug the program normally. Next, let's take a look at debugging a COBOL program that's been built to a dynamic linked library, or DLL. In this case, the calling program does not need to be in the same project, and it can be written in a language other than COBOL. This option allows you to debug just the COBOL DLL portion of the application. In my Start DLL project, I have the source code for my COBOL DLL subprogram. It's called with parameters passed in the linkage section. To debug this DLL, I'll go to Run, Debug Configurations, and on the left choose COBOL Application and then New. For project, I'll enter the name of the project, Start DLL. In Main Program, I'll choose the main executable that calls my COBOL DLL. Note that the calling executable does not need to be in the same directory as the DLL. Since my calling executable is in a different directory, I need to tell the COBOL runtime where to find my DLL. I'll go to the Environment tab of the Run configuration and create the environment variable code path. I'll set it to point to the directory within my DLL's project where the DLL file was built. Now, when I click Debug, the main executable is invoked. However, we don't see the executable in the debugger. As soon as my DLL is called, the debugger starts and positions me to the first statement in the procedure division. In the debugger, I can look at the linkage section to see the values passed from the main executable and step through the DLL's code. I can see that an O was passed into the linkage field link action code. When I exit this subprogram, the main exe runs outside the debugger. When the DLL is called again, the debugger picks up again, and we can see that a different value was passed into the link action code field. Next up, we have options to allow a running Eclipse debugger to wait for and attach to a COBOL application. This technique allows several different ways to control which COBOL processes the debugger will attach to. The first and simplest option is to wait for any debuggable process to start. To use this debugging option, I'll create a run configuration of type COBOL wait for application attachment. I'll enter the project name associated with the program I wish to debug. I'll make sure under Matching Options, Any is selected. Then I'll click Debug. If I look at the debug view, I see that the debugger is waiting for attachment. Now I can execute any debuggable COBOL application outside of Eclipse. In this case, a debuggable application is one that calls COBOL debug break, or one that is executed while the environment variable COB switch is set to +A. If I run a program without meeting this criteria, the program runs at full speed. If I set COB switch to +A and then run the program, the debugger attaches to the process and I'm able to step through the code. A variation on this is to wait for attachment from an executable run from a specific directory. To try this, I use the same type of debug configuration, but I add the specification of a directory to be watched. In this case, I don't want COB switch set to +A, so I'll make sure this is not set. Now I'll start the debug session and see it waiting for attachment. Because I've specified a directory, if I try to run the executable from a different location, the execution is not caught by the debugger and runs at full speed. I have a copy of the executable in the C:\work folder directory I specified in the configuration. If I start it from there, it catches in the debugger. The last option under Wait for Attachment is to wait for a program to attach, which is specifying a particular identifier. This option only works for native COBOL. I have a separate program to demonstrate this. In my debug configuration, I'll specify a program identifier. I'll use the string Blair as the ID. This means the debugger will only attach to a program that requests the debugger using this ID. The way the program specifies the ID is to issue a call to COBOL debug start, which is similar to the COBOL debug break seen earlier. But COBOL Debug Start allows you to specify parameters controlling how the program is to be debugged. One of those parameters is an ID that must be specified by the running debugger, or the program will not run under the debugger. Here, I'm specifying that the field Debug ID will contain the ID to be matched, and up in working storage, I can see that Debug ID contains the string Blair. This technique is useful for cross-session debugging, where you can have multiple copies of the debugger running and have a given copy of the application control which copy of the debugger will attach to it. If I start the debugger to wait to attach to a matching ID, and then I launch the program from the Visual COBOL command prompt, the debugger catches because the ID matched, right at the point where the call is made to COBOL Debug Start. I can continue to debug the program from that point. If instead I specify a different value in the debug configuration and restart the debugger to wait, then when the program is executed from the command line, the debugger never catches and the program runs to completion. Lastly, we'll take a look at remote debugging. This option allows me to debug a COBOL program running on a separate machine. This technique can be used to remotely debug applications running in production under the COBOL server product. In this case, I'll again be using a debug configuration of type COBOL wait for application attachment, but I'll expand the selection for connection properties and enter the IP address or machine name of the remote machine running the COBOL program. I also need to specify a port that will be used for debugging. In this demo, I'll call the remote machine my production machine. I have a remote desktop connection started to my production machine where my application is installed. Once again, that machine does not have Visual COBOL for Eclipse installed. It only has the product which is used to run your deployed programs in production, Micro Focus COBOL Server. In addition to the executable file being on the production machine, I've also copied the IDY file for the affected program there. To support remote debugging, I'll need to start a debugging engine on my production machine. I'll do this with the command cob debug remote, specifying the same port number of 5000 I used in my debug configuration back on my development machine. I need to start cob debug remote from the directory containing the IDY file for my program, or I need to set the cob IDY environment variable to point to the location of the IDY file. Now the debug engine is waiting on the production machine for a connection from a remote debugger. Back on the development machine, I'll start the debug configuration I created for this remote debugging. It now sits waiting to attach to a program on the remote machine. Returning to the production machine, I can see the connection has been established between the two machines. Still on the production machine, I'll start a new Visual COBOL command prompt and start the executable for the program. I'll set cob switch equal to +A so that the debugger will be invoked. Finally, on the development machine, I see that the debugger has fired up and caught the execution at the first statement in the program. If I was debugging a 64-bit program, the debugging engine I'd start on the production machine would be called cob debug remote 64 rather than cob debug remote. We've just seen the process for remote debugging for programs deployed to production on a Windows server. For programs deployed under Visual COBOL for Eclipse with Development Hub, which are deployed to UNIX servers, the process is slightly different. Here are the steps. On UNIX, the 32-bit remote debugging engine is called COB Debug Remote 32 rather than COB Debug Remote. Start the version that matches the bitness of your executable to be debugged. Specify port equals to choose a port for debugger communications. Once again, I'll start COB Debug Remote from the directory containing my IDY files. In Eclipse, ensure that the remote COBOL project containing the program to be debugged is open in the COBOL Explorer. Go to Run, Debug Configurations. Create a new debug configuration of type COBOL Wait for Application Attachment. By default, the project entry is populated with your remote project, and you cannot specify a different remote machine than your development machine. Blank out the project entry to allow you to change this. Reopen the section of the debug configuration named Connection Properties. Enter the remote host where COB Debug Remote is running and the port number you've selected. Go to the Source tab, click Add, choose COBOL Project, and add your remote COBOL project and remove Default from the list. Click the Debug Symbols tab, select Add, and choose the same project. Click the Debug button to start the debugger waiting. Finally, in a new session on the UNIX machine, invoke the program to be debugged. That brings us to the end of this presentation on advanced debugging in Visual COBOL for Eclipse. Thanks for watching.